Hi everyone. In last sessions, what we discussed? We discussed the Ansible and we completed our Ansible series. So today we are going to see our Docker. So it is a very important Docker and Kubernetes. So first we will discuss the Docker. After that, we are going to start our Kubernetes series. So what is the Docker? Docker is nothing but it is a containerization. So whenever we're talking about of the containerization is nothing but so in that, whatever we have the dependencies, number of softwares we require to run our application. So each and everything it will be taken care from the Docker side. Suppose if we have the one application, that application code I want to run it. Then what we have to do? We have to add the some dependencies. We have to require the software to run our application. Suppose whenever we're talking about of the any kind of the application, like we are going to develop one application in Java. So at that time what we required the we required the Java, we required the some dependencies because we are going to develop the one application, and we required the some front end technology. So at that time we can install easily for particular of the one machine. But once we develop it, then we have the number of machines because we need to the manage the number of environment. Then what we have to do? We have to install the all required software. We have to add all dependencies, whatever we required. Is it possible from the manual side? No, this is not possible from the manual side. Then what we have to do? We have to use the Docker. First, we will discuss here the Docker. So what is the Docker? Docker is nothing but it is a containerization. So that containerization is nothing but we can say called as a container equal. So this container, this is the container, this is the equal to the package application code and required softwares also. So we can say called as a we require the software. Whatever we have the container, in that container we have the packages, application code and require the software. But whenever we require the number of dependencies, we require the number of application in all machine. Then what we have to do? We have to install either manually, either we can manage from the Docker side. First, we will discuss here the application architecture. So what is the application architecture? So mostly any kind of the application, we have the three layers. One is a front end layer, second one is a back end, third one is a database. So front end is nothing but it is a user interface. So user can communicate with our UI part and they will get the desired output. Suppose I'm using of the hotel booking application. Then what we have to do here? So we have to search the hotel that particular of the city by using of the UI part here. Once we book it, then what will be happen? We will get the some message from the booking application side. Then all logic will be happen from the business logic. So whatever we are searching, then booking, and we are getting the some messages from the application side. Who will be managing? It will be managed from the backend side. And whatever we have the application data, all application data where we need to the store it, we need to the store in our databases. Because earlier we had a monolithic architecture, but nowadays we have the microservices. Microservices is nothing but we have the all separate things here for front end, for back end, and databases. You can develop front end any of the framework like Angular, like React library, like Vue.js. Then for the back end, so we can use the Java, .NET, Python, Node.js. It depends on our project requirement. And databases also same thing. Earlier, what was that? We had a monolithic architecture. So each and everything, so all layer, so we can say called as a first one is a databases. First one is a UI and second one is a databases. All communication will be happening in our one thing here. So we don't have any at that time business. We had a business logic. Whatever we have the front end data, that data we need to the catch it into the databases directly. But instead of that, nowadays everyone is using of the microservices. So that's why we can say called as a three-layer application here. So we can say called as a software application architecture. So any kind of the application. So it's a simple architecture, any kind of the application. One is a front end, back end, and third one is a databases. So these three things we have in our application. We can say called as a software application architecture. After that, we have the tech stack of the application. For the front end, suppose consideration here, you can consider I'm using the for front end Angular 18 version. For the back end, Java 17 version. For the databases, for MySQL. And server side, I'm using here the Tomcat. Why we are going to use here the Tomcat? Because we are using here the mostly Java. So that's why Tomcat is a we can say called as a comfortable for our Java. So mostly whenever we have the Java, then we need to use the Tomcat. So these three things we have the tech stack application. So suppose here the you can see the application environment. Like in real time, we will have the some several environment to test our application because are we going to directly develop the application into the live environment? No, we are not going to develop our application into the live environment. We will have some environment like dev, SIT, UAT, pilot, prod. Dev is nothing but so developer used used by the developer for the code integration testing because they are responsible that develop and they are responsible for the code integration testing. After that, for the SIT environment, it is used by the tester for the system integration testing because we can see called as a system integration testing. It is a full form of the SIT. After that, we have the UAT environment. UAT environment used by the team, client side, team side for the acceptance testing. So they will decide if our application will go live or not. Suppose if it is working as expected, then they can say called as it is a ready to production environment. We want to deploy in our production. If some it is not working as expected, then what we have to do? We have to work on it and we have to fix it. So this is the we can say called as a UAT environment. Then pilot. So what is the pilot? Pilot environment used for the pre-production testing. So it is accepted testing from the client team side, but some while we merging of the code from UAT to pilot, due to some reason, while we merging the some our code is not working while we merging the code UAT to pilot. So at that time, suppose we are not tested properly, then what will be happen? Same thing we are going to deploy in our prod. Then there are some blocker, there will be some incident. So avoid that type of the incidents. So we are going to test it from the testing side. It is a complete replica of the production environment because whatever we have the real time data. So all data will be presented into the UAT, SIT, all those things. But so here, whatever we have the previous feature, so all stable feature will be available in our pilot environment here. So in the pilot environment, so it is a complete replica of the prod environment. And we have the final delivery, we can say called as a prod environment. So final delivery is nothing but it is a live deployment end user can access our application. So this is the environment. But you can see here the we have the 10 machines, we have the 20 machines for 15 machines for 100 machines and 200. All machines we require. In all environment, whenever we managing at that time, so what we require? We required the some dependencies. We required some software in our machines because we can say called as a we need to the okay. So you can see here the okay. You can see here the in dev environment we have the 10 machines. So all 10 machines, I required the dependencies. I required the some software because we want to run our application code. Then same thing I required the in for SIT environment. Same thing for I required. Same thing for I required for the EVT. Then same thing for the pilot environment and same thing for the prod environment. Then what will be happen here? So we need to then install it. So whatever we require the software manually. So by using of the Ansible, we can use it. We can add the dependencies. But whatever sometimes we will get the some compatibility issue. So each and everything whenever we are going to install manually, then what will be happen here? So it will be there is a chance to mistake from our side because we are not using anything here. We are not using of the Docker and we are not using of the Ansible. Ansible is nothing but we are going to manage our machines. Whatever we require the configuration server, we are going to manage it. So already we discussed it. Same thing. I want to ins- I want to run my application code. So at that time, I require the some dependencies. So what is the dependencies here? So dependencies is nothing but so you can see here Maven tool. So we will discuss in upcoming session once we completed the our Docker and Kubernetes, then we will start our Maven. Maven is nothing but there is a no required to add the exe file in our project. Suppose I required the some database connectivity. I required the some Spring Boot here. You can see here the I required the Spring Boot starter Tomcat. So at that time, what we have to do? We have to install the jar files because this is the desktop application. Already we know that we have the two types of the application in the market. One is a desktop application, one is a web application. What is the extension for the desktop application? It is an extension for the jar for the desktop application, and you can say called as a exe file. And what about of the whenever we deploying of the web application at that time we have to wrap that all application code into the WAR file. So we can say called as a WebEx application. So each and everything, suppose I required this Spring Boot starter Tomcat here. At that time, what we have to do? We have to add the jar files in my IDE because I required the this Spring Boot here. So instead of that, we can add our Maven in our project. So we can say called as it is a form.xml file. So anyone is here from the coding background side, they are aware about of the form.xml file. So it is nothing but it is a Maven because we are going to use here the Maven tool. So we can say call it it is a automation tool, Maven tool. There is a we are going to add the dependencies and we can use it whatever we require the dependencies for our application. So I'm developing one application. I require some jar files. So there is no need to add the jar file. Instead of that, we can add the dependencies. You can see here so when I click on the this here, you can see here the Maven. So you can add these dependencies instead of that jar files. So because whenever we are going to add the jar file, so it will be managed. It is difficult to manage because sometimes we are upgrading our project from particular version to the from particular version. So that's why instead of that, you can see here we can see the versions. This is the maven. Whenever we using of the maven, we have the gradle also. We have the number of things here also. So you can see here by using of the maven, we can use here the add the dependency. So these are the dependencies I require because I want to run my application code. Then what we have to do here? Either you can add manually, either you can add from the Docker side. So whenever we are doing these things from the manually, then what will be happen here? There is a chance to doing the mistake here from the human side. Instead of that, we can use the Docker, and by using of the Docker, so we have the containerization. In that containerization, we have the some packages, whatever we required to the install the some we required, whatever we have the all dependencies, each and everything will be taken care from the Docker side because we want to run our application code. So that's why we are going to use here the Docker. But suppose I'm not using the Docker, then what will be happen here? Suppose I'm not using the Docker. You can consider here this is my application here. Then this is the you can consider here this is the UI. This is the second part is the business layer and databases layer. Whenever I'm not using the Docker, then what we have here? Then we need to install the dependencies, then software in all machines manually. So that is the fine. But suppose developer developed the code, they tested properly, and it is working as expected. Then they push the code into the this first environment. We can call it as a dev. Then they push the code into the SIT environment. Then tester team will be start to the testing because just they want to test it. Whatever the features are developed from the developer side, it is working as expected or not. If it is working as expected, then we can say it is ready to UAT environment. Either it is not working as expected, then we can say we need to develop, we need to fix that bugs. But at that time, developer said, whatever I develop the code, whatever I develop the feature, it's working as expected in my machine. But whenever we deploy the code onto the server into the SIT environment, that code is not working because here we have some issues, configuration issues here. We have some compatibility issues here because we you can consider here I used here the X version and I used here the X2 version. Then what will be happen here? So it will be get an error here, some compatibility issue because we have the we X version and we have the X2 version. Then what will be happen here? So developer has to debug the code why this code is not working to the SIT environment. Then what will be happen? It is a time taking process because whenever we debugging the code, we need to debug line by line why code is not working as expected. So this is the problem we can say code and sometimes we are not scalable properly. Whenever suppose I want to scale the application, so it is a difficult to the scalable by using of the manual configuring and copying the application binaries data, then manually setting up the load balancer. So it is a difficult because number of machines, number of things, each and everything we required manually here. Instead of that, we can use here the Docker and we can say called as a you have to handle it each and everything in all environment. So all application code will be run in our properly in all environment whenever we using of the Docker. So in in upcoming session we will discuss in deeper without Docker how we can say call it without Docker how our life is going, and with Docker our life is very easy because whenever using of the Docker, so there is a no configuration issue, there is a no compatibility issue. So easily we can configure, easily we can scalable our application. Suppose whenever using of the heavily virtual machines, suppose I'm using here the number of virtual machines to managing. So VMs are very large, but it is a slow to the start it. And because we have the number of resources, that resources are very hungry to consuming our virtual machines RAM. So at that time, what will be happen? Our machines will be very slow. So then what we have here already we discussed. We required the 10 machine, 20 machine, 15 machine, each and everything we required because we have the different environments here. That's why by using of the Docker, we can say call it the each and everything will be managed from the Docker side because Docker is nothing but it is a containerization. Containerization is nothing but suppose you can take example of the I want to ship the some materials from one place to the another place. Then what we have to do? We have to load the material into the container. Okay. So we have to load the material into the container. Then ship will be start to the shipping to the one place to the another place. Suppose if we are not load the material into the container, then what will be happen? Then we can say call it the all material will be like this, like this, like this. So is it managed to the all material? No, it is not manageable. So that's why we are going to structure that material into the container, and all container we are going to move from one place to the another place. Same like this here, Docker. So Docker is nothing but it is a containerization. That containerization packages application code, all packages, application code, and we require the software, we require the dependency. So each and everything will be managed from the Docker side. With doc, with the help of the Docker machines, very easily. Suppose without Docker, what will be happen? Sometimes it will be get configuration issue. Sometimes it will be take version issue. So instead of that, we can use here the Docker and easily we can run our application any machines very easily. Docker will take care of all dependencies, then all installation software, whatever we require to execute our application code. So that's why we can say call it the with Docker life is a very easy. As a DevOps engineer, we can say call as a otherwise we can say call as a our application life is a very easy. So we can make our application portable using of the Docker because whenever we using of the manual thing here, so there is a chance to mistake and there will be some configuration issue, compatibility issue, number of things will be happen in our without Docker. So instead of that, we can use the Docker easily, and by using of the Docker, we can manage our application code and we can execute our application code any of the machines, whatever we have the machine. All machines we can suppose whatever we have the application code, then we can easily execute our application code any of the machines also very easy with Docker. So that's why Docker is a very important here. So Docker is nothing but it is a containerization. So just we have to keep in your mind Docker is nothing but we have the ship container. That ship container, we have the package, then application code, then require the software. So it will be wrap in the Docker. It is a wrap in our container and it will be execute easily any of the machines also. So Docker is a free and open source software. In upcoming session, first we will discuss the Docker architecture. After that, we will we will complete our Docker setup in our Linux virtual machine. Because already we know that how we created here the setup for the Ansible. Same thing, we need to install the Docker. So I think that's it for Docker. Uh, not not a Docker. That's it for today. In upcoming session, we will start our Docker architecture and we will start our Docker setup in our Linux virtual machine. Then we will start our some commands we need to execute in our Docker. Let's see, we will have the some 10 to 9 commands we have to keep in our mind. Then we are going to host a number of application. Like suppose I want to host the application using Java related. Suppose I want to host the Python related. We will see how we can execute, how we can deploy our different technology application into the uh, deploy in our Docker. And how, let's see, in upcoming session we will discuss our practical sessions. We will discuss it and we will understand why Docker is a very important. Because without Docker life, without Docker, it is a difficult life to our application to manage each and everything. With Docker, it is a very easy life to our application. So I think that's it for today. In upcoming session, we will start our next topic. Thank you guys.